An exclusive interview now. A top doctor, our guest here. His name is Dr. Shiva. He has more accomplishments than I can mention in an introduction. He holds 4 degrees from MIT, a doctor, a PhD in biological engineering, who studies the immune system daily. But the man who at the age of 14 in 1978 invented email, yes, the inventor and copyright holder of email. Oh yes, Dr. Shiva, welcome to the Next News Network.
Great to be here, Gary. Thanks for having me. Most people in the field of immune systems don't really understand the science of immune systems. If you ask a typical doctor, if you ask them, well, what is a virus and how does the immune system work? They actually think that the virus is some big boogeyman. You know, it's got big claws like alligators, and it goes into your body and starts eating your tissues, right? Like the Ebola thing, and you spew blood, and the vaccine blocks that, okay? That's their understanding of the immune system, when it's far from that, and we can talk more about that. If you actually understood the immune system, it's laughable. The reality is the immune system has evolved over billions of years. We grew up in bacteria and viruses. We're supposed to play out in dirt. That's how the immune system gets turned on. So what happens is it's people who have immunocompromised immune system. So it's your own body attacks itself because of a weakened and dysfunctional immune system. Well, how do you get a weakened and dysfunctional immune system? Well, eat crap all day, eat sugar all day, okay? Eat a diet that's no longer has any vitamin D and nutrients. The people for years who've been victimized by dirty air, dirty water, dirty food, their immune systems are compromised. Now, look, also as you age, right? Your thyroid function goes down, your HCl levels go down, your vitamin A levels will get suppressed, right? And you don't get enough vitamin D, and nor is your body able to really do proper digestion, right? So what ends up happening in this entire process, you have weakened immune systems.
Today, I really want to talk about the immune system as your body's operating system. And a couple of principles we want to talk about is resilience, which is one of the most important features of any system that survives and succeed, is the ability for it to take a hit and then come back stronger than it was. And natural systems, man-made systems which survive, really have this property of resilience. So we're going to go. So when your immune system is in good shape, the rest of your body takes care of itself, okay? That is called homeostasis. From an engineering standpoint, we would call it your body's natural system state. You know, think about the times when you felt great, right? You're eating all the right foods, you're happy, you're in the right environment. Your body just is, you don't even have to think about it, right? Your body's, all of its systems are working properly. That's what I mean by homeostasis. Well, as we've talked about, in order to get your body to homeostasis, you need to fuel it with the right ingredients, with the right inputs, and then your body can stay on track. Now, body has a homeostasis, and you're cognizant of it through your awareness, through your observing yourself, and you're making minor adjustments. Weather changes, you go on a long flight, you have stresses in your family. So as long as you're keeping in check, you make these minor adjustments to keep your body back in homeostasis. And if you do that, your body will take care of itself. In this time of the coronavirus fear-mongering, where everyone's at home, as I keep saying, it's a really important point to start reflecting on how we make sure that this never occurs. Again, when I say this, that we don't get caught into this fear-mongering, and we have our own resilience and strength to be confident, to understand that, you know, our body wants to be healthy. And there are 380 trillion viruses in our body. There's nearly 60 trillion microbes across the 6 trillion cells that we have. So when we look at it, our body has learned how to survive for many, many millennia, whether you believe in natural design or evolution, whatever it is, the body was designed to survive in these circumstances. So what is the goal of, what is a strong immune system? Is a strong immune system where you quarantine someone, where you give people antibacterial soap, or you hide your kids from playing out in dirt, and you essentially wash and wipe down anything? Is that what we call a way to build a resilient immune system? Do you build a strong body, but being on the couch, not doing anything, essentially protecting your body, living in a little bubble? Probably not, okay? Unless you're some other kind of super being. But by and large, if you do those things, in the case of the immune, you're actually hurting your immune system because you're never stressing it. We're going to talk about that. Same with if you don't stress your body with exercise. So one of those aspects is called stress inoculation. I have studied the human body and have created a whole new way of looking at it through an engineering approach, which I can teach anyone. And that's the basis of a whole set of courses I have called Systems Health, which developed after my Fulbright work. I used to teach at MIT, and I've made it a course offering, and we're trying to figure out how to make it accessible to all of you very shortly. But the bottom line is your body is a system, and the body has principles. And you don't have to go to medical school to understand those principles. In fact, a lot of MDs have gone through this course where you can really start understanding how your body is a system and the engineering principles. But one of those principles is resilience, is a resilience of your body. So if you go here and we really look at this concept, what is resilience? Well, one way to think about it is use it or lose it. Okay, so again, those people are on Instagram. This will be up there on IGTV, but the slide really says use it or lose it. That's a good way to look at resilience. And to understand that, we need to understand what stress is. And this is the notion of engineering stress. And then if you take a course in stress mechanics at a place like at an engineering school like MIT or others, you'll understand a very, very interesting concept that materials, when you want to measure their strength, if you want to start pulling them apart, they'll have a point where you can pull them apart and they bounce back like a rubber band. You pull them apart and they bounce back. If you pull it apart too much, it'll change its structure, which means you won't be able to come back. And if you pull it beyond that, it fractures. And a good way of looking at that is this diagram right here, okay? Very simple, simply put. You can put a strain on it, which is pull it, and this is a stress. And the stress of this object, expands, and at a certain point you can fracture it. So you have to be careful how much you stress something. You don't want to stress it too much, but it needs a certain amount of stress. So this would be when you come to the immune system. Imagine if you live in a pristine environment and you never see anyone, you're quarantined, no one ever sees you, you don't touch anyone. That's one kind of position where you're not stressing the system. The other thing is you're living in slums, constantly being stressed all the time, constantly being attacked by many, let's say, pathogens and viruses, and your body never has a chance to recover. That's where you can quote unquote fracture. That's the concept of a stress that goes to the extreme. All right? Now, resilience, there's various definitions. Resilience is defined as here's various definitions: the ability of your body that has been subjected to an external force to recover its shape and size following deformation. That's from McGraw-Hill. A measure of a body's resistance to deformation. The ability to recover quickly from illness, change, or misfortune. And the next one is the ability to adapt in the face of trauma, adversity, tragedy, or even significant ongoing stressors. So what I'm trying to say is that strength is, can you take a hit and can you come back to where you were, or can you come back even stronger? That's a measure of resilience. So if you start working out physically, and you're not a couch potato, initially you may feel some pain the first day, the next day less pain, you get stronger and stronger. That's the concept of resilience. So this concept comes into the immune system also. If we provided, you support it with the right foods and the right environment. So that's the point I want to make. We're not, our body's not some weakling, okay? So if we go back here and we really explore this a little bit further, one of the important things that this research showed, if you look at this, there are 4 aspects of what they call stress inoculation to get the body resilient. So how do you get the body resilient? So there's 3 things, whether it's immune system or your psychological system. One is, your genetics. That's one part of it. That's not everything. Then we have epigenetics. What the recent research that came out of 2003 with the study of the Human Genome Project is you're not just your genes. Genes can be turned on or off, and that's called epigenetics. And the third thing, and listen very carefully, is stress inoculation. Stress inoculation. What that means is your body needs to be stressed. So this diagram best exhibits that. So in this paper that came out, you have genetics, which are your body's ability to generate certain types of proteins that are important for managing stress. Stress inoculation, where you're actually training your stuff to early life experiences. For example, were you around dirt, or did you get exposed to viruses when you were young and pathogens? This is called resilience therapy. And the third is epigenetics. All these 3 things, if you see right here on the bottom, reads to resilience, stress, active coping, and increased fitness. Okay, so again, coming back here, your genetics, your stress inoculation, which means inoculating your body with stress. Those stresses could be exercise. Those stresses could be exposure to viruses, exposure to bacteria, and epigenetics, which is what you do to your body to support your genetic framework. What foods you eat, what exercises you do, what environment you're exposed to. So just think about that for a second. That we're talking about this triangle of inoculating yourself with stress, getting enough, you have this certain amount of genetic makeup, but you can make that up in many ways. It's not all or nothing. So in this case, your genetics can be supported with stress inoculation or epigenetics to achieve this thing called stress resilience. Okay, and in the area of neurobiological stress, what they've noticed is things like adaptogens. Okay, so we're really looking at a particular a neuron here, and what you can see is if you take adaptogens, your body will actually release this neuropeptide Y, and neuropeptide Y supports subsystems in your body that you actually get resilience. So what are adaptogens? Well, adaptogens are those things that come from certain adaptogenic herbs. So for example, ashwagandha, ginseng. There are a whole variety of herbs, and in fact, if you inoculate yourself with stress, that also releases these neuropeptide Ys. So neuropeptide Y is something that supports, we're looking at psychological stress. And similarly, there are things for immune stress. So bottom line is there's a chemical and a biological basis that your body wants to be stressed, okay? And by the way, what you're seeing here, it's a very interesting curve. So I want to use this word stress inoculation. Okay, we've talked about, the big pharma guys want to inoculate us with their vaccines, with aluminum and mercury. But the aspect of inoculating yourself with a stress, that stress could be you go lift weights, you run, you are exposed to sort of wacky people in your office, you learn how to become resilient over them, or you're exposed to pathogens. And that pathogen exposure gets you stronger, assuming that you're properly feeding your body and you're not immunocompromised. Okay? The key is if you're not weak and immunocompromised over a lifetime of not exposing yourself, hiding yourself, or not giving yourself the right nutrients. But what you see in this very interesting research that they did in the field of neurobiology here is that here is the normal person. Okay, this is this dark line. And if you stress inoculate yourself, which is the dotted lines, two things can occur. A, you get better performance, which means for the same amount of stress, you get higher performance. That's this curve, this dot. Or for higher levels of stress, you get increased performance, okay? So what's amazing about this is what this is saying is that your body wants to be stress inoculated. That your body wants to be stress inoculated. In fact, there's some very interesting data that has been shown that when people have been, for example, during the Spanish flu times, the military actually did some very interesting experiments, and this is out there in the literature, and I'm going to do a special talk just on this, where they took people who had the flu and exposed them, and took, let's say, X number of people had the flu, same number of people who didn't have it, and literally took the mucus and all what may sound very disgusting and gave it to the other people. You know what? They didn't get sick. The second thing they did was they took these same people and injected these things into them. They didn't get sick. And the third group, they had people talk among each other and they didn't get sick. I'm going to share this shortly. What's fascinating is that you have to really wonder this whole thing about, social distancing, don't expose people. Is that in fact correct? Maybe that's true if the person is not resilient. Not for people who are strong, who are not immunocompromised. Just like what this is showing here, that you actually improve performance when you get exposed. Okay? So what Fauci is doing out there, and the entire pharma industry is based on fear-mongering and ignorance. Through fear and ignorance led by Fauci, is that the entire economic policy of the United States is being driven. So big pharma, in collusion with the big banks, is doing one of the biggest frauds in the history of the United States, for that matter, globally. Do you want to get her question on?
Yeah, just ask a question if you like.
Okay. I heard from some news source that that unlike other viruses, once we had it, we don't necessarily develop an immunity. So they said people in China were getting reinfected. So I wondered if that's true, if you know anything about that.
Yeah, so first of all, you have a lot of people who don't understand science, okay? And the question you asked is based on this thesis that viruses are what harm us and kill us, okay? What does everyone think? Oh my God, the coronavirus is going to hurt me, right? Isn't that sort of the general thing? Well, it's not the virus that hurts or harms you.
What is it?
Good question. Now you're asking the right question. What is it? And so why is it in a city of Wuhan of 11 million people, they had 2,000 deaths, let's say. Let's put all the deaths over to them. How many deaths are there right now? Maybe 10,000? Let's say all the deaths were attributed. So why is it out of 11 million people, only 10,000 had the deaths? Why? Well, that means different people's immune systems respond to the pathogen in a different way. Okay? So what is actually going on is this. Point 2. It is the overreaction of a weakened and dysfunctional immune system. It's a reaction of your immune system. Okay? It's an overreaction of this system that leads to you getting ill. So what do I mean by that? The overreaction. So what happens is when a virus particle, if you've seen those viruses that you've probably seen with all those little spikes coming out of it. So if you look at that, the virus has 3 parts to it, okay? The suction pieces, which tries to attach to a cell wall, the surface protein around the virus, and then inside of that bubble that you see is the actual virus RNA, its nucleotides, okay? And so what happens is this virus particle is running around, and it tries to stick itself on your cell. That's what those proteins are. And then it tries to inject its nucleic acids into your body. And then once it gets that into there, it uses the machinery of your own cell to replicate itself. Okay? The surface of that stuff that sloughs off, that glycoproteins go to certain parts of your body. The Ebola virus, that surface protein, goes to the arterial endothelial cells in your heart and arteries. In the case of coronavirus, it goes to the epithelial cells in your lungs. Okay? Now, what happens when you get hit with the virus is that the virus is attacking you, or coming into you. Your body, in the natural case, like I shared with you, the innate immune system turns on. You don't even notice this happens. You get a little cough, and that's why the mild cases, your adaptive system kicks in, and you don't even notice you even got it, right? There's so many viruses that you and I have, you don't even notice it, because this is naturally happening. Your body knows how to handle it. However, if people's immune systems are weakened and compromised, what do I mean that by? You've heard underlying pre-existing conditions. What are they? Obesity, okay? Diabetes, you're immunocompromised, and I'll come to that. Or you have smokers, right? Well, what does immunocompromise mean? As you age, or if you're a young kid, it can happen to both. Immunocompromise can occur. There's many modalities, but I'll give you 2. One is if your thyroid is not functioning right, okay? If your thyroid is not functioning right, you know what happens? Your body doesn't produce enough vitamin A. So how does your body create vitamin A? From carotenoids in food. Forget taking the supplements. Eat the good vegetables which have carotenoids. Your thyroid takes that and it converts it into vitamin A. I'll come back to vitamin A. Second, so as you age, your thyroid levels drop. You don't produce as much vitamin A. The second thing is as you age, or if you're ill as a child, your gut doesn't produce enough hydrochloric acid. HCl, hydrochloric acid. What is Acidophilus? You've heard of Acidophilus? It's a good bacteria. It means the bacteria which love acid. Phyllis, acid, okay? So if you don't have enough acid, what happens? Your bacterial levels change, which means your gut microbiome changes, which is one of those subsystems I shared with you. So your gut microbiome is affected, and your thyroid level drops, and you don't have enough vitamin A. This is what happens when people are immunocompromised. These are 2 very important systems.
can happen to kids, it can happen to elderly people. Now, as people age, this naturally happens. Thyroid levels drop, right? That's why the 40 deaths were people 40 plus years old. 50 plus years old. It may occur to young kids too, but young kids typically have a stronger system. Why is vitamin A important? Well, when that virus lands on the cell, it's trying to get in. Well, vitamin A creates cytokeratin, okay? What is cytokeratin? It's like the building blocks of the walls around your system, okay? That's what it is, every cell. So if you look at every cell, Hal, if we have my connector, it's okay, but I'll show you a picture after, but around every cell, the cytokeratoids literally build a wall. So when you have enough vitamin A, your cell is protected. So guess what? Viruses can't get in.
This is really about immune health. This is the fact that we don't get enough vitamin D, we don't get enough vitamin A, we don't get enough vitamin C. There's other things, but we can focus on those three things. So the solution is pretty simple. At least get out in the sun. If you can't do that, you got to boost up on vitamin D, vitamin D, vitamin D. Vitamin D, I'm going to be doing a video on this to explain this to people, literally creates through a set of pathways very interesting molecules which are the fuel to your macrophages. Where does vitamin A come from? The dark, rich vegetables and fruits, okay? And where does vitamin D come from? The sun. So it's like basic stuff. Fruits and vegetables, get some sun, okay?